So in this problem it says ball of mass 8 kilos is suspended by 2 wires from a horizontal arm which is attached to a vertical shaft as shown in the figure right here. Then it says the shaft is in uniform rotation about its x-axis such that the linear speed of the ball equals 2.3 meters per second. They're asking us to find the tension in wire 1. Okay, so as we know, there's a circular motion going right here, and this is the radius of rotation. Now in this circular motion, we maintain the plane of rotation constant. So acceleration is going this way, and so is the force. Now, in regards with the force, the sum of all the forces in the y direction, we got mass times acceleration being equal to 0. In regards with the sum of all the forces in the x direction, we got the mass times the acceleration in the x direction, which is the same as the mass times the acceleration of the center. And that formula that we're going to use is going to be mass times velocity squared, all divided by the radius. So in the y direction, we got 3 forces. We got T1, T2, the angle theta, and the weight going down. So we also know that the weight is going to be T1 plus T2 cosine of theta. Now as we know the sum of all the forces, we can set up an equation regarding the y direction, and that's going to be T2 cosine of theta plus T1 minus mg equal to 0. And for the x direction, it's just going to be T2 sine of theta. Now sine of theta is going to be 0.8 divided by 1, and cosine of theta 0.6 divided by 1, based on the graph. So this is the angle, opposite, adjacent, and 1.0 is going to be the hypotenuse. So as we do that, let's first find T2. We know sine of theta is 0.8, we know the mass, the velocity, and the radius. As we do that, we get a value of 66.13 for tension 2. Now, to find T1, we gotta use equation 1, which goes like this: T2 cosine of theta plus T1 minus mg equals 0. As we do that, we end up T2 as cosine of theta equal to the mg minus T1. As we continue doing the algebra, we end up with T1 being equal to 40.3 newtons for tension 1.